Lockheed Martin's F-35 Lightning II, the modern battlefield's single most visible answer to integrated air dominance. You hear the name, and you picture a shape that refuses to be fully seen: faceted surfaces, internal weapons bays, and sensor apertures that fold the battlefield into a single, coherent view for the pilot inside. This is not a legacy fighter in camo and chrome. The F-35 is a fifth-generation multi-role stealth combat system, a sensor, a shooter, and a network node all in one airframe. Out front, it shows you numbers Mach 1.6, roughly 1,200 miles per hour, and a ferry range measured in the neighborhood of 900 nautical miles. But numbers only tell a fraction of the story. At the heart of the machine is the Pratt & Whitney F-135 engine, a propulsion package designed not merely to deliver speed, but to deliver the thrust and thermal management that advanced avionics, directed sensors, and internal weapon carriage demand. In short bursts, it gives the F-35 the burn to sprint. In sustained operations, it gives the jet the reliability to remain a persistent sensor and strike asset in contested airspace. There are three basic variants of the Lightning II: the F-35A, the conventional takeoff and landing model that fills the classic fighter role; the F-35C, built for carrier operations with reinforced landing gear and larger wings for arrested recoveries; and the F-35B, the short takeoff/vertical landing STOVL variant, a design that redefines where fighters can operate. The F-35B's STOVL capability allows it to land vertically like a helicopter and to take off from very short runways. That ability to operate from austere, short-field bases and a broad range of maritime platforms gives commanders a flexibility that older runway-dependent fighters simply cannot match. From an operational standpoint, the F-35 is built around sensor fusion. Think of the pilot's helmet as the human-machine interface for a distributed consciousness. Data from the jet's AESA radar, distributed infrared search and track systems, electronic warfare suite, and other onboard sensors are fused into a single, prioritized battlefield picture. Targets are tracked, threats are highlighted, and engagements are coordinated sometimes before the enemy even knows they're being painted. This is a leap away from pilots individually interpreting separate streams of raw data. Instead, the F-35's systems present the mission in a way that lets the pilot act decisively and quickly. In the tactical crucible, that fusion capability changes how air superiority is achieved. Rather than relying purely on kinetic reach or missile capacity, F-35 formations create a net sensors and shooters cross-cueing one another, handing off tracks, and enabling long-range, multi-axis engagements. An F-35 can detect a threat with its own sensors, validate it against data links from other platforms, and either prosecute the target itself or vector a wingman with a different ordnance profile. The advantage isn't just survivability, it's tempo. In modern combat, the side that can sense, decide, and act faster wins. The F-35 was designed with that cycle in mind. The F-35B variant writes new doctrine for expeditionary operations. Imagine a forward littoral assault ship, a damaged airfield, or a hastily prepared expeditionary strip. A Harrier once symbolized that capability. The F-35B modernizes it. With vertical landings and short takeoffs, it can embed air power with amphibious forces or lift from small decks that were previously the domain of helicopters and tilt rotors. That capability matters not only in hot conflict but in gray zone operations, deterrence patrols, and power projection. The mere presence of fifth-generation jets operating from forward locations reshapes the adversary's calculus. The cost of this capability is not trivial. Production and sustainment place the F-35 among the most expensive fighter programs in history. Individual airframes carry price tags in excess of $100 million, and the full life cycle expense logistics, spare parts, depot maintenance, Software upgrades amplifies that figure. But cost and capability are measured differently in modern militaries. The investment buys survivability in contested environments. Internal weapons carriage reduces radar signature, advanced countermeasures and low observable shaping increase mission survivability, and sensor fusion multiplies the combat effectiveness of every sortie flown. The F-35 has been exported and adopted by a growing roster of partners and allies. Beyond the U.S. services, nations such as Japan, the United Kingdom, Italy, and South Korea have taken the Lightning into their fleets, integrating it into joint force architectures. The U.S. Marine Corps operates the F-35B specifically to sustain its expeditionary air-ground task forces, giving the Corps a modern, stealthy strike and close air support capability that can accompany amphibious operations and littoral maneuver. To understand the F-35's place in aviation history, you must understand the lineage of vertical and short takeoff and landing concepts. The Harrier family showed the world that a fighter could operate without long runways, using vectored thrust to thrust hover and transition to forward flight. That lineage continued into the F-35B's engineering, but with modern stealth, sensors, and a shaft-driven lift fan that allowed the aircraft to perform vertical landings without sacrificing the low observable characteristics required for survivability in contested airspace. This thread of takeoff innovation also connects to the naval concept called the ski jump, an upward curved ramp that imparts an upward vector to aircraft at the end of a short flight deck. By forcing the aircraft briefly upward, the ski jump allows planes to become airborne at lower airspeeds than a straight deck would permit, a critical trick for carriers that do not have catapult launch systems. The Royal Navy famously adopted the ski jump with its Harrier trials in the 1970s and integrated it into the Invincible class carriers. Today, navies and amphibious platforms continue to use ski jumps and STOVL-capable aircraft to maximize the operational output of smaller decks while minimizing the complexity and cost of catapult systems. Operational employment of the F-35 family is not limited to large, showpiece strikes. The jet's true value is often in subtle distributed uses: suppression of enemy air defenses, SEAD, with precision standoff weapons, electronic attack to blind and confuse adversary sensors, and intelligence, surveillance, and reconnaissance, ISR missions, where the F-35's sensors collect against prioritized targets and feed higher-level networks. Picture an F-35 over a theater as both scout and a guardian, its sensors sweeping the electromagnetic spectrum while its data links relay handoffs for long-range fires or airborne tankers, repositioning to extend the reach of fewer aircraft. From the logistics bench to the tactical pilot's seat, the F-35 program is a software-defined airframe. Capabilities improve through software blocks. New sensors come alive in the field via updates, not just hardware retrofits. That means the jet can evolve with mission requirements, implementing new algorithms for sensor fusion, updating data link security, and integrating fresh weapons as they come online. But software dependency also creates operational demand. The supply chain, secure maintenance facilities, and a trained workforce become force multipliers, just like fuel and munitions. Strategically, the F-35 complicates an adversary's targeting problem. Low observable characteristics cut detection windows. Fused sensors mean that even if a platform is detected in one spectrum, other systems are already tracking and compensating. The presence of F-35s in a theater forces changes in enemy doctrine, greater dispersion, new emission control policies, or a heavier investment in counter-stealth sensors. For Allied planners, that pressure can be leveraged. A few forward-deployed F-35s, operating from austere locations or Allied decks, can project deterrence disproportionately to their numbers. There are real and present limitations. No aircraft is invulnerable. In contested, denied environments, The F-35's advantage is relative. It improves the survival odds and mission success, but it does not guarantee them. High-intensity conflicts demand combined arms planning. Air, sea, land, cyber, and space must synchronize. The F-35 is a key node in that broader network, not a standalone panacea. Commanders must still manage attrition risk, logistics throughput, and the political costs of deploying expensive, visible assets into harm's way. On the training range, pilots and maintenance crews learn the true value of the Lightning. Pilots practice sensor management under duress, learning to prioritize threats and hand off engagements to wingmen or remote shooters. Maintenance teams focus on sustainment cycles, low observable treatments, jet engine logistics, and software updates. The program scale means that industrial partnerships and allied basing agreements are as much a part of the F-35's operational calculus as fuel and munitions. In the end, the F-35 Lightning II is a study in modern trade-offs: cost for capability, complexity for adaptability, stealth for presence. It is a jet optimized for the battle space of the present and the near future, a contested electromagnetic environment where information dominance is the decisive factor. When flown by trained crews within integrated commands, the Lightning enables new forms of maneuver: distributed, networked, rapid, and precise. For those who plan operations, the hard truth is this: dominance is no longer measured solely by who can throw more metal into the sky. Dominance is measured by who can perceive the battlefield earliest, who can fuse that perception into actionable decisions fastest, and who can strike with precision before the enemy closes their sensor aperture. The F-35 does not promise invincibility, but it does promise to be the force multiplier that shifts that speed and accuracy heavily in favor of the commander who can integrate it into joint forces. From Harrier-era ski jumps and vectored thrust pioneers to today's stealthy sensor fusion platforms, the evolution of STOVL and carrier aviation is ongoing. The Lightning stands squarely in that lineage, a machine built for the sensor-heavy, networked, and dispersed operations of the 21st century. Where it flies, the rules change. Where it operates from improvised bases or small decks, the theater changes. Where its data flows into allied networks, decision cycles compress. Lockheed Martin's F-35 Lightning II is more than an aircraft. It is a modern doctrine accelerator, a tool that forces planners to think differently about basing, logistics, and lethality. For those preparing for conflict in contested airspace, the Lightning is the benchmark that every adversary studies and every ally wants in their inventory. Its presence is the new metric for expeditionary reach and joint force lethality.